Dear students, welcome to EPG Pathshala. I am VN Prabhakar from the Archaeological Survey of India. In the paper on principles and methods of archaeology, we will be discussing on the post-excavation analysis of archaeological artifacts in this module. So in the course of excavation, we do the destruction, because once we excavate, we remove the archaeological layers and deposits, we are totally destroying the ancient habitations. So it is an irreversible process. So we need to be very careful, we need to be very methodical in documenting and retrieving the data, and it is an unrepeatable experience, because we cannot go again and again to do the excavation to find the same kind of things. Once it is removed, it is gone. So we need to be very careful. And what we find here, materials, culture of the past, human beings, commonly known as the artifacts, which are humanly made or modified portable objects. It may be anything, it may be a stone tool, it may be a pottery and metal weapons, it may be anything. So these artifacts, they actually help in understanding the human past, and it is with these artifacts we tend to understand the past culture, past technology, past functions, what kind of trade and contacts, how they utilize the local environment, all these kind of things are there. So in this module, we will be understanding about the post-excavation analysis, that is, after excavation we retrieve the artifacts and what kind of analysis they can be done on the artifacts, and along with possible scientific investigations. I will be also discussing about certain scientific investigations that can help in understanding. So there is a wide range of things we find from the archaeological excavation. So this can be broadly classified into based on the material, based on the raw material. It may be a stone artifact, it may be a metal artifact, it may be ceramic or pottery, and it can be organic remains. So broadly, 4 categories I have done here, but there may be more and more categories also. But these 4 categories we will be dealing one by one here. And even while carrying out the excavations also, it is not only the post-excavation analysis or research that is important. It is during excavation also we need to be very careful, and there in the site itself also we can retrieve the data in a more scientific and methodological manner. So in the first instance, the soil samples, whatever we are excavating, they are more important. We can retrieve the soil samples, we can sample them at relative depths from the surface, label them and keep them safely for having various scientific investigations. Like we can do the phytolith and the pollen studies. We can do these kind of phytolith studies of the to understand the past plant remains, because the phytoliths, they consist of silica based inorganic materials that are preserved for a very longer period of time, and they have different morphology depending upon the plant species. So if we do a microscopic study of the phytolith, we can understand what kind of plant remains species were there. Similarly, pollens, they are better preserved in the lake like environment. So wherever there are evidence of paleo lakes or ancient lakes, we can do a core drilling or even excavation to retrieve the soil samples in which the pollen again is studied. So the organic samples, they are also retrieved during the course of excavation using flotation techniques. I mean, there are very simplistic flotation techniques are available. We retrieve the soil samples, put in a bucket of water, the simple organic materials, they float on the surface, they can be sieved and kept into, and that can be studied. So the charred grains, the grains that were accidentally fired and charred during the ancient environment, they are very easily detected using these flotation techniques. And even the micro charcoal, which are very good evidences of understanding the past plant species, they can also be retrieved, and these can be treated and studied under a microscopic environment by the paleobotanists, because it requires a specialized understanding of plant species, their morphology, their identification. So there's a separate branch of archaeology known as paleobotany, in which the botanists, they study the remains like the char grains, phytolith, pollens, and other microcharcoal remains to reconstruct the plant environment during the past. So coming to the post-excavation thing, I mean, one is the, I quoted an example of how during the excavation itself we can do a preliminary sort of research, preliminary sort of identification using a microscope. Even in the field also we can do the preliminary understanding. But coming to the post excavation, we retrieve the faunal remains also from excavation, so that is studied by archaeozoologists like paleobotanists for botanical remains, archaeozoologists for faunal remains. They kind of identify the species, whether it is a domesticated one or the wild variety. Then from that we can reconstruct the diet, then grazing patterns can be identified, the migratory patterns can be identified. If we use more sophisticated scientific technologies like isotopic analysis can be used to understand the migratory patterns, and the paleo diseases can be identified. So there are also human modified items which are found from the excavations, and these are of several classes. From the archaeological find, this can be studied in terms of human exploitation and how they were responding. The past humans have been responding to the environment. So these are all the various kind of things which we find from the archaeological excavations. So now we will study one by one. We have seen stone artifacts and the metals and the ceramics and other kind of classification which I showed you. So one by one we will be studying about the artifacts. So first we take up the stone artifacts. The stone artifacts are plentiful. It may be a simple stone tool datable to the Paleolithic period, or a sophisticated bead of the Chalcolithic period. So there are various kind of things, and again they are the best preserved one because it is inorganic in nature, and based on the hardness of the stone material they are preserved very well. The hardness of the stone, they are measured in a scale of hardness from 1 to 10, known as the Mohs scale of hardness. 1 is of talc and 10 is of diamond. Diamond is the most hardest of the ones. So they are classified as per the hardness also, and based on the specific gravity. These are all the preliminary tools. I mean, how to know whether it's a stone of talc, or what is the raw material, steatite or quartz. So these kind of simplistic tools can be used to identify, and more specific answer can be obtained by measuring the specific gravity of a particular sample. So once this kind of preliminary analysis were completed, then more detailed understanding can be done. What kind of understanding can be done? We can inquire into the raw material of the stone. We can inquire into the provenance analysis. Provenance means from where this raw material came. For example, a stone found in Harappa, in the Harappan civilization context, may not be locally available. They might have obtained it from a very distant area. So this can be understood. I mean, like a quartz material, it is found only in the Gujarat area. But if it is found in Harappa, then we can fairly say, without even scientific analysis, okay, this could have been come from the Gujarat area. So that is the provenance, from where it is originated. So we can also understand the technology of manufacture, how the certain kind of, if it is a tool, how it was manufactured, that can be understood. And various scientific tools can also be used to understand the technology. And then we can do the statistical analysis. I mean, what kind of stones are used predominantly, whether it is a locally available stone or it is coming from outside. So this can be understood using a statistical analysis. Then the functional aspect, how these tools could have been used, what kind of techniques can be used to understand the function of the artifact itself. So these are all some of the key aspects, and how a raw material identification. Raw material identification is the first step to understand the prehistoric economy. For example, even if you go to the prehistoric context, coming into the Mesolithic or the Upper Paleolithic period, we find certain change in the materials. In the prehistoric age, normally they were using the locally available material. Either it may be quartzite, it may be even basalt, limestone. Various kind of stones that are locally available were used for making the hand axe, choppers, cleavers, various kind of tools. But if we come to the Mesolithic or the Upper Paleolithic period, we suddenly start to get siliceous materials like agate, carnelian, chalcedony, and they were used for preferred for making the stone tools because they were very hard, and again it can be used worked very easily also in certain contexts by heating these stones to a certain degree of temperature, and this can be hafted also. And basically these siliceous materials, they are mostly of the basaltic origin. So it gives a clear indication. If the siliceous materials are found far away from the basaltic region, then we can clearly say there is a contact developing between different groups of people and how they were interacting with each other. So raw material identification helps in provenance studies also, and also the prehistoric economy, how the humans they contact between each other, even for the economic benefits. They might be trading also, they might be giving back something else for also. So the provenance study is a very important aspect in understanding the cultural and economic interaction of the past societies. It can be carried out by both visual examination, as I told you, just looking into the stone, the structure, we can say what kind of category of stone it belongs to, and also scientific investigation. So the visual examination, it can be carried out by identifying the distinguishable markers. I mean, whether the grain size also is one marker, and also the specific gravity is also one marker. That is a slightly scientific technique. But if you look into the structure of the stone by simply looking into the surface, then we can also make broad-based classifications. And we can see during the prehistoric period, the local, as I told you, local raw materials were preferred, and gradually the advancement in culture, it indicates long-distance trade. Gradually, when they developed, they were acquiring more and more, they were coming into contact with the distant cultural complexes, and they were importing exotic materials also. So for example, here I have shown the example of how the grinding stones, because in the prehistoric society or the protohistoric society, when the humans started to settle down, they were producing agricultural products, they were producing wheat, barley and various other crops. They have to grind them to make a flour, to make something edible to eat. So what happened, the grinding stone becomes a very important component of the protohistoric economy. And in the case of Harappan civilization, we are seeing the Harappans, they are searching far and wide for better quality grinding stones. Grinding stones with very good percentage of quartz or quartzite, it becomes really hard. So they are mostly preferred. So here there's a map showing how the grinding stone from the Kalyana hills in northern Haryana, it has been transported to various localities of the Harappan civilization. Ultimately, it is reaching Harappa. Harappa is nearly 400 or 500 kilometers from the raw material source. So this sort of economy, it was thriving in the 3rd millennium BCE just for the sake of grinding stones, because they need to have a very harder material for the grinding various cereals. So similarly, we can also look into the technology of manufacture, how the stone tools could have been manufactured. So just understanding the technology of manufacture, we can also understand which period it belongs to also. So the technology of manufacture started roughly around 2 million or 3 million years ago, depending upon the region from where it comes from. The stone tools are the earliest remnants of the human culture. They were manufactured using different technology. So archaeologists, they use different terminologies to define them, like Oldovan, Acheulean, Levalloisian, and all these kind of things can be seen in the literature. Also, we have various this kind of tool technology. They have a clear-cut markers on the stone tool itself, whether it is a direct percussion, whether they are hitting the stone directly with another stone or a hammer stone to remove the flakes, or they are using a indirect hammer technique. So these kind of things can be understood looking into the flake pattern, looking into the radiation pattern, how the negative flake scars are there. So this can be very easily understood, because the soft hammer technique using wood hammer or antler, they were used to remove very smaller flakes in a very controlled manner. So these kind of things can be very easily understood looking into the manufacture. And looking into the manufacture also, we can understand what kind of important hammers they could have used that, and how they could have held the stone, whether it is a right-handed technique or a left-handed technique. All these kind of things can be understood. So another technique which emerged during the Mesolithic or the later Upper Paleolithic period is the pressure flaking technique. So it was used during the Upper and the Mesolithic period to produce stone tools of very exceptional shape. We can remove flakes of very small size using soft tools, and to have a very sharp edge or a very desired shape can be obtained. So the replication, how we also understand the technology, because the replication we do the experimental studies. The many pre-historians, they have really advanced in this. They exactly reproduce the same kind of tools, imagining the same kind of technology, and try to understand the manufacturing process. Even the various stages of manufactures can be understood. From the prehistoric period onwards, entering into the various technological stages, coming into the age of the Chalcolithic period, again the stone was used continuously. The stone was not discarded. Like Chalcolithic means they were using copper as well as the stone. So in the Chalcolithic period, the classical example is the Harappan civilization, where they were obtaining a particular type of stone from the Rohri area in Sindh, and they were exporting into all parts of the Harappan civilization. So Harappan region, they were trading these things also, and they are using a different technique to kind of flake these things also. So they were also, during the same process, they understood the stones can also be used for making different kind of ornaments. So different kind of ornaments can be produced. The smaller and the bigger beads can be produced, and they have to drill these beads also, because they have to make a perforation so that it can be strung as a necklace. So in order to understand what kind of tools they might have used to make perforation, I mean, we use replication studies which was perfected by Professor Mark Kenoyer. So in this silicone impression of the bead hole impression is made, and then it is studied under scanning electron microscope. There's a various kind of images have been shown here. You can understand how various techniques produce different kind of surface morphology. The top right is of a copper drill, how repeated use of copper drill, it heats up the copper drill, it has to be, it flares up, it bulges out, it has to be cut again, polished, then again reused. So you can see the various kind of bulges on the surface, but on the bottom left, the two images on the bottom, they were manufactured using a special type of drill known as earnestite. The Harappans mastered the use of earnestite. They used this drill type to make very perfect bore holes of these beads of siliceous materials. That's why the surface is very smooth and polished. The bottom right one, extreme right one, is of a modern example. It is from a modern bead from Khambat, where even today the bead manufacturer uses double-tipped diamond drill, because the double-tipped diamond drilling technique came around the first millennium BCE, and it was perfected later on. So even today, the Khambat bead manufacturer, they use the double-tip diamond drill, and you can see the deep grooves cut into the stone, because diamond being very harder, so this can be very understood. So looking into the surface morphology, we can understand various kind of bead drilling technology. Next comes the statistical analysis. So this statistical analysis, it is done based on various kind of analytical measurements. If it is a stone tool, you can measure the length, breadth, thickness, and also the angle of the bulb of percussion, the angle of the striking platform. So all these things, if a very good considerable data set is there, we can define patterns. Similarly, in the case of beads also, we can do various kind of statistical analysis to understand is there any pattern emerging, if there is any local pattern is there, if a bead is manufactured from a particular site, it can be tallied with the drills found from the site also by measuring the borehole impressions. So these kind of things are also possible as an extension. Next comes the functional analysis. This is one very important aspect on what the stone tools might have been used. They were manufacturing different type of tools, but for which purpose exactly they were using. So one technique is the microtopography. I mean, because continuous use of the stone tools on any surface, it clearly chips very minute fragments, and if it is viewed under a microscope, we can understand the microtopography. So these kind of things can be used, and also continuous use of stone tools on materials like leather, wood, or even crops. It produces a polish. Some kind of polish is produced for when it is used for a continuous period of time. So these kind of polishes can be detected under a simple binocular microscope, and it has been classified. At least 6 type of polishes have been identified based on the materials they have been used. They are wood, bone, hide, meat, antler, and non-woody plants. So these different categories of materials, if they were cut using a stone tool, they give a clear polish on the surface. So these things can be very easily detected using a microscope and can be developed. And similarly, how one can test this? Same replication can be done, experimental studies, duplicating the same kind of tools, then using them on different kind of materials, and again viewing them under a microscope gives a comparative analysis of the polishes also. So this is a functional aspect. Then comes the organic remains. How the organic remains can be understood or studied using the scientific techniques. We have seen the stone tools and the stone beads, manufacturing, functional, all those things, and how organic remains can be studied. Organic remains consist of different categories. It may be a bone, wood, antler, shell, ivory, textile, leather, anything. But again, depending upon the preservation conditions, we find very few organic remains, because if it is the preservation conditions is not suitable, they will all decompose and completely disappear, unlike the stone artifacts. So this is very difficult. Even the technological markers on the stone tools or the bone tools or wooden tools, it is very difficult to understand also. So it is very difficult to even retrieve the organic remains, because they might be decomposed easily. So it is very difficult. But certain organic remains of the shell artifacts, they are very well preserved because of the nature of the material, and we can understand from the waste products and the finished products and the technique of manufacture. Because if we look into the discarded materials, particularly from the historical context and the Harappan context, we can see very good impressions of the saw they were using to cut the shell, complete shell. So this is useful in understanding the technique of manufacture of shell products, because they are preserved well. Otherwise, if you look into other textile remains or the leather remains, it is very difficult to find them. So wood is a very important component. If you look into the earliest examples of wood remains in the Harappan context, we have wood remains from the burials. The wood senators were preferred of different woods, but again it is not well preserved. Okay, it decomposes depending upon the preservation conditions. But it was a very important building material. Wood were, along with other bricks and stone, they were being using as a building material. Even farming material would have been manufactured. Furniture was one of the other important item. Boats, sheep, carpentry tools, toys, figurines, you name it, they might have manufactured many different items. We have examples of descriptive evidence of these kind of wooden materials from other civilizations, but we don't have from the Indian context, because they are preserved very well in the marine or the dry environments. But the very well preserved some of the wooden remains are from the Great Pyramid of Cheops, where a dismantled cedar wood boat is completely preserved here in one of the chambers. They might have used this boat to carry the funerary remains, and then they dismantled it and kept it there itself. So this is a very good evidence of how they were manufacturing the boats. But in the Indian context, we have very less remains. We don't have this kind of wooden boats or wooden transportation material, but there are certain exceptions. We have a wooden boat canoe from Pattanam. It was excavated and datable to around the early centuries of the Common Era. So we have a wooden canoe there, and also one wooden boat was excavated at a site known as Kadakarapalli in Kerala, where also they have found the remains of a wooden boat. It helps to understand the kind of manufacture, how they were combining together the wooden planks and all to manufacture the entire boat. Next comes the plant fibers. How we can understand, how we can study the plant fibers. Plant fibers, they are completely decomposed. It is not at all found. They are very rare in the archaeological context, but they were being used from the very earliest period, like in the context of megalithic, in the context of Mehergarh, in a site in Pakistan. We know from the Neolithic period around 7000 6000 BCE, they were using cotton thread to string a copper bead. So we have evidence like that. But how they are found? I mean, they are found kind of in a very good environment if the copper minerals are there. So copper minerals, they help in the preservation of the plant fibers, and apart from various plant fibers also, they might have used bamboo for manufacturing baskets and other tools, because we have evidence from the pottery, impressions of bamboo corded basketry sort of thing on the pottery, or the bottom surface of the pottery, or on the surface of the pottery. And also the arrowheads, they preserve evidence of certain bamboo species also. So these are all kind of indirect evidences which are really helpful in understanding the plant fibers or the plant remains during the ancient period. Whereas there are scientific techniques, it can be also be used to understand the kind of plant fibers, even identify the species also. Like you can see how the fibers or the plant remains from a copper bead, because the copper minerals, the copper minerals help in the preservation of these organic remains. And two examples are quoted here. One is from the site of Harappa, where a copper bead was found, and inside that the silk thread was found. So looking at the morphology of the thread remains, comparing with the modern morphology, it can be understood that it could be thread. The bottom one is from Dholavira, where again from inside a copper bead we found thread remains, and again when it was viewed under a scanning electron microscope, it proved out to be either cotton or jute. So these kind of understandings can be done. And plant remains and the fibers, since they are very rare in the archaeological context, these kind of indirect techniques have to be used to investigate them. So next come the analysis of inorganic remains. Inorganic remains, they are the best. They are preserved very well. It consists of, again, a very large category of objects. It may be pottery, it may be metal objects, both ferrous and non-ferrous, consisting of iron, gold, silver, copper, bronze, lead. It may be anything: glass, faience, stone objects, beads, tools. So it can be anything, and there are wide category, and there are again different techniques that can be employed for understanding the various things. The pottery is one among the most numerous finds from any excavation, and it because it is burnt to very high temperature, it becomes very hard, so it is also preserved very well. Again, pottery production, it is very difficult, and the ancient humans, they have mastered this technology, control of the fire, how in a closed environment the temperature can be increased even up to 1000 or 1100 degrees centigrade. So the pottery manufacture indirectly helped in the smelting of metal ores also. So this is everything is related. The pyrotechnology or the control of the fire, which was very much helpful in creating various kind of artifacts. So this pottery technology in the Harappan context, again, it is very well understood from sites like Harappa, and even in the Indian context, we have sites like Barot, Tarkanwala Dera, Khirsara, Rakigadi, where evidence of updraft kilns have been found. This is a special type of kilns. You can see from this slide how for nearly 700 years the same area in Harappa, which was used by the potters, okay, smaller sized kilns dating back to 3300 BCE to the latest to 2400 BCE, the larger sized kilns. So they have been found. And the right extreme is the very good example from a site known as Khirsara in Gujarat, excavated by the Archaeological Survey of India. Even up to the platform, the kiln is very well preserved. You can see there is a platform there, and there is a large opening for putting the fuel there. The firewood is placed below the platform level. It is burnt to very high temperature. Then the heat is radiated through the smaller holes you can see on the platform. Then there is a dome covering on the top. So inside a closed environment, the temperature reaches very high temperature, and the pottery could be manufactured, and the desired color and desired the strength can be obtained. So, but how do we understand using scientific techniques and the pottery technology? So the pottery technology lies in the a selection of the clay, what kind of clay they select, how they navigate, how they sort out the various kind of clay, how they filter out the various impurities. So these things can be understood by a thin section study. We can cut a thin slice of the pottery, then view under a polarizing microscope to understand the various kind of mineral inclusions, then calculate the statistics of the mineral inclusions, then we can understand what is the grain size, whether they are using a smaller grain size or the bigger grain size. So if the smaller grain size, they are sorting out the clay, they were cleaning the impurities, they were removing the unwanted things, and they were receiving it and obtaining a very fine paste. So these kind of techniques can be identified, and again we can compare the clay from the pottery as well as the raw material sources. We can collect clay from the nearby clay sources and then compare them. So these kind of studies are available. Again, sophisticated equipment can also be used using scanning electron microscope with EDX or energy dispersive X-ray analysis and X-ray diffraction. They can also use to understand the mineral composition of the pottery, and again the clay can be analyzed to correlate. So the reserve slipped ware or RSW of the Harappan period, which is a distinct ceramic type found in the Kutch region, it has been studied extensively, and these kind of ceramics, they are found in the Kutch region and also Mohenjo-daro, Chanhu-daro, and some sites in Mesopotamia. So these pottery have been studied extensively, and the technology has also been understood. Another class of ceramic is this kind of cooking vessels. It is a carinated cooking vessel, very typical of the Harappan period. The left one is a hallmark Harappan cooking vessel, the right one is the local imitation. So looking into just the shape of this cooking vessel, one can understand it belongs to the Harappan period. So similar type of ceramics are found even in distant regions like in Oman region. So this clearly indicates movement of Harappans from one place to another place. So looking into the shape and the type, then these kinds can be understood. How do we understand the pottery provenance? Like briefly I touched before, the chemical analysis from the pottery can help in understanding for what purpose they are used apart from the provenance. Provenance I touched briefly. Along with the provenance, we also understand what purpose, the functional aspect of the various kind of property. When the pottery, when they are used for storing various kind of materials, it can be milk, it can be oil. So if they contain fatty acid and amino acid, so it penetrates into the surface of the pottery, it gets into the pores, and that can be analyzed using spectrometer and a technique known as chromatography, which help in identification different components of fats. So this is one technique, and also analysis of the lipids, starch granules, and also DNA biochemical analysis of plant residues. This can be studied by scraping a portion of the interior of the pottery, then doing the cleaning process and viewing under a spectrometer to understand the various functions. So we have been seeing various kind of tools, ceramics that have been used by the humans, and one class of artifact used by the past humans is faience. Faience is an object which is also known as the early form of glass, because if the glass is a more refined form of faience. Faience is manufactured using crushed quartz particles mixed with flux agents and coloring agents to produce various kind of materials. Like you can see, faience was used in the Harappan context to produce bangles, buttons, beads, and various kind of figurines also. So this can also be studied using a microstructure analysis, like this study have been done by Mark Canoyer. So two different type of manufacturing processes have been identified from the Harappan context. You can see the left hand one is more coarser and the right hand one is less coarser, very fine. So one type of faience is more coarser, and another type of faience they were making it very fine paste and manufacturing. So this kind of broad-based understanding can be done on what kind of materials they were manufactured using this kind of faience can also be tallied with the evidences. And one more category is the glass. As I told, the faience is the early form of glass. When they refined the technology, glass, they could produce glass, and in the international context, the glass was produced around 2500 BCE, but in the Indian context, we have glass around 1200 BCE, they were used for producing various kind of objects and artifacts. And again, it is manufactured using silica, silicon dioxide basically, and alkali oxide, then using lime, which is used to stabilize the mixture, and so to make it less soluble in water, so under coloring agent. So all these kind of things, using a certain manufacturing process, they could produce glass. So how do we understand glass? I mean, glass coming from different region, how one can say this glass is coming from India, or it is coming from Persia, it is coming from Egypt. So we can do again chemical analysis. One is the typological analysis, because different culture produce different products, a different type of materials and artifacts. So that is culture specific. But also, if you want to look into the composition of the material, so we can say from where they came from. Again, there are various kinds of instrumentation techniques are available, X-ray based techniques are available, then microscopic techniques are available. Even the most sophisticated one is the LAICPMS, that is given here, laser ablation inductively coupled mass spectrometry. So it is a nearly non-destructive technique. A laser beam is penetrated into the glass artifact, then it measures the various chemical composition, and from that we can understand from where it could have been done. One such study was carried out from a site known as Kopia in Uttar Pradesh by Alok Kanungo. Here the various kind of glass artifacts and the crucible in which the glass was manufactured, it has been displayed. So finally we come to the metal artifacts. How the metal artifacts can also be studied. There are various categories of metal artifacts. The copper appears very early in the archaeological record, around 5th millennium BC in the South Asian context, even though native copper was used, because the copper available in the native or the natural context, they can be beaten and hammered to produce various kind of artifacts. Because copper, it is very easy to work when compared to iron, which appeared very later when the ancient humans, they reached a very high temperature. So there is a natural progression also. The copper appears very earlier, then the last stage is the iron. So in between we have silver, lead, gold, all these metals appear in the archaeological record. So how this can be studied? Again, typological studies can be carried out, and also sophisticated instrumentation techniques like X-ray fluorescence, XRF for the compositional analysis, optical emission spectroscopy. There are various kind of techniques which can be used to understand the composition of the various elements within the copper, bronze artifacts or other materials. The trace element analysis, there is one more technique which is which measure the rare earth elements. It can be also studied using a methodology known as neutron activation analysis for obtaining the minute details and also the composition in a very detailed manner. So ultimately it can be also used to understand the provenance. So another important technique used for provenance, particularly the copper, lead and silver artifacts, is the lead isotopic analysis. Isotopes, they have the same atomic number but different mass number. So there are various elements of the same atomic number but different mass number. So they are categorized, and they are radioactive as well as non-radioactive. So the radioactive ones are unstable and the non-radioactive ones are stable. So the stable isotopes, even though they are non-radioactive, they are formed due to the radioactive decay of the another element. So these things can be used for understanding the provenance. The presence of stable isotopes in metals and their ratios, it helps in the understanding their provenance. So as the ores are coming from different sources, they have different isotopic values. The ores coming from Rajasthan, northern Rajasthan, southern Rajasthan, like copper, they are obtained in northern Rajasthan, southern Rajasthan, even Balochistan. So all these different sources, they have different isotopic values. So if these materials, they are analyzed, then we can delineate from where they are coming from. So the lead isotopic studies of copper, lead and silver, it can be very much helpful in identifying the sources, because lead is always present in very minute quantities even in copper and also silver. So again, this is measured using various instrumentations. One is the thermally ionized mass spectrometry known as the TIMS, and another is the inductively coupled plasma mass spectrometer, that is ICP-MS. So they are very highly sensitive and they can even measure values up to part per billion. So an example of this kind of studies is done by Randall Law of University of Wisconsin. So he uses a technique known as EDTA. He uses ethylene diamine tetraacetic acid. It is a chemical which is used to leach out the radioactive material. So it's a 0.05% in very pure water. It is used to leach out the isotopic isotopic components from these metal artifacts. So these artifacts, they are dipped in a bowl with a solution for 5 to 10 minutes. Then the artifacts, they are taken out, cleaned and dried and repacked. Then the solution, it is measured in the instrumentation which I mentioned, and we can develop plots, these kind of plots. So different regions have the different isotopic values, and from this plot we can say from where they are coming. If we measure the isotopic values of these artifacts and we plot them against the isotopic values of the raw materials, we can very easily pinpoint from where they are coming from. So this is copper, then this is lead objects from Dolavira, and we also analyze the silver object. These are the silver objects, and everything have been platted. So based on this analysis, a map has been developed. So from this map, we can understand the various regions from where these Dolavira Harappans, they might have got the different materials. For example, copper, it could have come from the Ambaji and the southern Gujarat, Rajasthan border, and also from Balochistan, one distant source of Balochistan. Some are coming from northern Rajasthan. You can see the wide range of places from which they are getting. And silver and lead also came from Ambaji, because Ambaji also has silver and lead remains, and also from southern Rajasthan sources. So this kind of variability, this kind of long distance trade really can be understood from this kind of scientific techniques. Otherwise, visual examination, it will not tell anything. No kind of information can be understood from the visual examination. Only the scientific examination leads to large leading to answering answers of very important questions. Another important aspect is the metallographic analysis, how these metals themselves might have been manufactured. So it is looking into the microscopic structure of the metals, like cutting a thin section and viewing under microscope. Then we study them of the various phases. How, whether they were annealing was done, forging was done, cold working, every part of the manufacturing process, it leaves a certain impression on the microstructure. So that can be analyzed, and the various manufacturing techniques can be identified. So one is the provenance, one is the functional, and another is the manufacturing technique of the metal artifacts. So we have been looking into the various categories of artifacts: stone, organic, plant remains, inorganic materials, and how they have been studied using typological studies, as well as manufacturing studies, functional studies, statistical studies, and also metallographic or the manufacturing techniques. So these kind of very broad-based, wide variety post-excavation analysis are available. It is not only useful for the typological aspects, technology, manufacture, provenance studies can be easily understood. The typological studies is only a preliminary sort of looking into the visual aspect of the artifacts. It gives a cultural aspect, how the different culture produce different kind of materials, and also cross-cultural references can be obtained. If material of one culture is found in another culture, we can say there is a borrowing. So influence and symbology. So these kind of things can be studied using the typology. But for better understanding of artifacts in a spatio-temporal context, then we need to have scientific analysis, which briefly I touched upon during the course of this lecture, and also various instrumentation techniques used for identifying various category of the elements, compositional analysis, provenance, and other things. But always a selection of a suitable instrumentation technique is essential. It is not that every technique can be applied to every material. So we have to select a proper instrumentation technique so that better results can be obtained. So you can refer into other parts of this module to understand. You can read the e-text to have more detail about other techniques also, and also the references part to develop your studies further. Thank you.